Hello everyone. Today we are going to explore the foundations of artificial intelligence. So it is one of the most exciting and rapidly evolving fields in modern science and technology. Artificial intelligence or AI did not emerge out from nowhere. It is the result of centuries across many different disciplines based on human thoughts, from ancient philosophy to modern computer science engineering. So, in this session, we will walk through various key disciplines that shape the AI. So, we will talk about philosophy, psychology, mathematics, economics, neuroscience, computer science and engineering, control theory and cybernetics, and then we'll talk about the linguistics. So, by the end, you will understand how these fields came together to create the intelligent system we see today. So, first, we will talk about philosophy. So, first, we should understand AI is a multidisciplinary field. Okay, so we will talk about each of these disciplines in detail and what is its contribution. So let's start with the philosophy. So it is the oldest contribution of or towards AI thinking. Philosophers ask some of the most fundamental questions about intelligence. So can formal rules be used for correct reasoning? How does the mind come from the brain? Where does the knowledge come from? And how does the knowledge lead to actions? These questions are not just the philosophical curiosities, but they are the very design challenges that AI researchers face. Now, we will talk about various early thinkers about the AI. So, some of the earliest contributors to AI, like thinking, were ancient and Renaissance. First, we will talk about Aristotle. Aristotle, around 350 BC, introduced the concept of syllogisms. This is what we discussed in the last video. Okay, so it's about logical reasoning patterns. He talked about logical reasoning patterns. So he introduced the laws of rational thinking. So we saw one example, na? All men are mortal. Socrates is a man, from which we concluded that Socrates is mortal. So this kind of formal rule-based reasoning is a direct ancestor of expert systems in AI. Next, we will discuss about Raman Lull, who proposed that reasoning could be done by machines. Right? Next, Thomas Hobbes said thinking is like doing essential computations. It's like doing calculations. Then came the mechanical computing pioneers after this. Leonardo da Vinci designed an early mechanical calculator. Then Wilhelm Schickhard built one of the first calculating machines. Then came Pascaline, which was created by Blaise Pascal, which adds and subtracts. Then Gottfried Wilhelm Leibniz built a calculator that was able to multiply and divide. So these early thinkers were planting the seeds of idea that machines could eventually think and act like human. Now philosophical ideas about mind. So now let's look at the theories about philosophical theories about the mind. Because AI is ultimately about creating minds or at least simulating them. So first we'll talk about the rationalism. So rationalists like Aristotle and Descartes believe that knowledge comes from reasoning. Descartes also proposed dualism, that the mind and the body are fundamentally separate entities. This question still debates AI researchers. Is intelligence purely physical or is there something more than that? On the other side, materialists argue that mind is simply the result of the physical brain. This is a view much closer to modern neuroscience and AI. When you talk about empiricists like John Locke said, knowledge comes from the sensory experiences. Okay. David Hume extended this idea with the induction that we form general rules by observing patterns repeatedly, just like the syllogism patterns. Think about like a child, if you observe a child who learns to recognize a cat. So child learns by seeing multiple cats of different sizes, different colors. So this is essentially how a machine learning or how the machine learning works today. Okay. In 20th century, thinkers like Rudolf Carnap, and Russell developed logical positivism. The idea that knowledge is equal to logic plus observation. Statements must always be verified through experience. Observation sentences connect our knowledge to the real world. So, this framework where everything must be grounded in some kind of logic and evidence, this became the foundation of how AI systems are designed to reason and verify information. So, when we talk about knowledge and action, Aristotle, as brilliant as always, gave us a framework for intelligent actions. So he said, intelligence requires both thinking and acting. Okay? His model was simple but very powerful. So he said that goals plus knowledge will give you the action or lead to action. Suppose, let us consider this example. So if I need warmth, a cloak gives the warmth. Therefore, I will make a cloak. He even described a basic decision process. First, decide your goal. Find the means to achieve it. What are the ways to achieve it? And then choose the best possible action. This is essentially the goal directed reasoning used in AI planning systems today. So, what is a summary? To summarize, philosophy laid the conceptual groundwork for AI by asking the right questions. So, what are those questions about? About the reasoning process, about the knowledge, how the humans think, how it learns, how it acts. So, without these philosophical thinking, we wouldn't have a framework for what AI should even be trying to do. Next, we will discuss about mathematics. Now, let's turn our to mathematics. So, mathematics in AI asks some of the questions like key questions. What rules help us to draw correct conclusions? What problems can be computed? And how do we handle uncertainty? So, these questions can be answered. The first mathematical contribution is logic. So, we discussed in the first session like logic, the logical representation in uncertainty, what was the difficulty. Now we will see how this is being handled. George Boole developed the Boolean logic in 1800s that says true or false reasoning, or we can say zero or one system that underlies every computer chip ever built. Gottlob Frege extended this with first order logic. In first order logic, you try to say everything in objects and relationships. For example, suppose all birds have wings. Suppose if I talk about this first order logic, suppose if I have all birds have wings and I say Tweety is a bird, therefore I can conclude that Tweety has wings. So Alfred Tarski connected logic to the real world systems. So logic helps AI system to reason and make decisions correctly. Okay. The next major contribution is towards computation theory. So what can be sought? Okay. So already we discussed about Alan Turing. So one of the founding, he was one of the founding fathers of computer science. We discussed about that. We'll talk about this. So what is an algorithm? It's a method to solve problems, like we can say Euclid's GCD algorithm. So, Kurt Gödel provides the theory or the theorem for incompleteness. So, he says that some true statements cannot be proven. Already we discussed Alan Turing defined the computable problems using Turing machines. So, not all problems can be solved by a computer no matter how it is powerful. So, this is called as the computability limit. Okay. So, as discussed earlier, the problems can be solved mathematically if it has a proper uh, theorem. So, this then came the concept of tractability. That is, even if a problem can be solved, can it be solved efficiently? So, you have to check the efficiency. That's very important. Problems that take exponential time, like to solve, are called intractable. That is why breaking big problems into smaller, manageable pieces is an important strategy. So, what we discussed here, we talked about incompleteness theorem, and then we talked about Turing machines by Alan Turing, and then we talked about tractability. Now we'll talk about NP completeness. That's the hard problems. So this was developed by Stephen Cook and Richard Karp. So it represents the class of extremely very difficult problems that cannot be solved using larger inputs. Many real world optimization problems in AI fall into this category, which is why we often use approximation algorithms instead of exact solutions. Now, we will talk about probability, that is handling uncertainties. Giorolama introduced the concept of probability. Then, Blaise Pascal and Pierre Fermat developed the probability theory. Thomas Bay gives the Bayes rule for updating the probabilities. So, this Bayes rule is a method for updating beliefs based on the evidences. For example, when I look or before I look outside, I believe that there are 30% chances of rain. Then I see dark clouds. So Bayes' rule let me update my belief to maybe 80 percentage. So the kind of reasoning under uncertainty, that's very important, right? Because real world problems are fully filled with uncertainty, is a fundamental idea to modern AI. Finally, mathematics gives AI decision theory and game-based theory. Utility measures how good an outcome is. It's AI way of quantifying the values. Choose the best action based on the outcome under uncertainties or decision theories. So study decisions involving multiple agents. Okay. So this is critical for AI systems that interact with human or other AI agents. So we talked about philosophy, we talked about mathematics. So to summarize, mathematics provides the foundation for AI with three essential tools: logic for reasoning, computation theory, and then probability for handling uncertainty. So these are the two areas we can see where it was a foundation for the AI system to evolve. Now we will talk about economics. What does economic have to do with AI? Again, economics in AI to answer three more questions: how to make decisions to maximize the payoff, what to do when others actions affect us, how to decide when rewards comes in the future. Okay, so Adam Smith, the father of modern economics, described how individual agents trying to maximize their benefit, okay, both at the system level at larger outcomes. So AI system are often modeled the same way. Okay. Next, we will talk about the concepts. Let's look at the concepts one by one. First one is utility. So utility measures the desirability, how desirable an outcome is. Okay, how desirable an outcome is. It should give maximum benefit. Then comes the decision theory. It uses probability and utility together to make the best decision under uncertainty. Next is your game theory, handles multiple agent interaction. Okay, so it studies decision making where multiple agents are involved, where one's action affects the others. Next is the operation research. It focuses on optimizing decisions in complex and real world problems. Next will be your Markovic decision process or MDP. Provides a framework for sequential decision making where actions happen over time. So this MDP is the backbone for modern reinforcement technology. The last is satisficing, a term coined by Herbert Simon, describes something very human, choosing a situation that is good enough but not necessarily optimal. Real intelligence is about satisficing and not optimizing. That's very, very important. Then to summarize, utility defines what is best. Decision theory shows how to choose under uncertainty. Game theory handles interactions with others. MDP and operation research deals with long term decisions. Satisficing reflects the real human decision behavior. So, economics help design intelligent systems that make optimal or practical decisions in uncertain, interactive, and dynamic environments. Next, we'll talk about neuroscience. So, we have talked about mathematics, philosophy, and then economics. Next, we'll talk about neuroscience. It is the study of how the brains and the nervous system process the information. Humans have long been fascinated by the brain. So we will be thinking like how does the brain learn, do the actions. Now Aristotle observed that humans have a large brain relative to the human body size. Injuries to the brain affect thinking, showing that the brain is a seat of intelligence. Okay. So, the basic question like, can we build a machine that works like a brain? That's very important, right? That's what we are trying to do. We will talk about the brain structure and function, mapping and learning, and measuring the brain activity. So, brain is made up of approximately so much of neuron, like 86 billion neurons. It is a basic computational unit in the nervous system. Paul Broca discovered that the specific brain areas control specific functions, for example, speech functions. Okay, a specific area it controls like the speech in the brain. Okay, so this locality of function inspired AI architectures where specific module handles a specific task. Like it's all built of neuron. Na? Each neuron will take one specific task. Camillo Golgi developed a method to see neurons. So this was the paved way for Santiago, who studied neuron structure in detail. Okay. So when we come to brain mapping and learning, different brain areas handle different tasks. So we do multiple tasks. We move, we do movement, we jump, we walk, we see, we hear. So brain is very, very flexible. Functions can shift if a particular part is damaged. So we should be very careful. Exact method of memory storage is still unknown. So we store millions of information, like from the childhood. If you imagine, see how much of information is being stored. Okay. So when you talk about measuring the activity, so Burge invented EEG to measure the brain signals. Okay. So modern MRI, let us see which brain regions activate during our task. Like when we run, what happens? Which brain is activated? When we laugh, which part is activated? Scientists can now observe individual neuron responses to the stimuli. And these observations directly inspire how we design artificial neural network. To summarize, neuroscience help AI by explaining how the brain processes the information, inspiring the intelligent systems like neural network. Nowadays, deep learning, the technology, powering image recognition and voice standards and large language models, all these are inspired by the brain architecture. Next, we will move our discussion towards psychology. So, it is a study of how humans and animals think and act. So, which is very relevant to building an intelligent system. It's very direct. Hermann Helmholtz studied that human vision using scientific methods. Wilhelm Wundt opened the first psychology lab in 1879 and used introspection, that is, studying one's own thought. This we already discussed in cognitive science. So, this was used as one of the research method. But what is the limitation? Introspection is very subjective and always not reliable. So, AI needs something more rigorous. So, when we talk about the behaviorism and the cognitive psychology, John B. Watson led the behaviorism movement. Okay, with the concept of stimulus and response. Okay, so the study only what you observe and ignore the internal thoughts that are not measurable. So, whatever you are not able to measure, ignore that. Whatever you observe, you take that. Okay. Work well for animals but not fully for humans. Okay. Now, when we talk about the cognitive psychology, that is a revolution in thinking. So, brain is like an information processing system. Okay. So, William James supported early cognitive ideas. And Kenneth Craig proposed brain builds the internal modules of the world. His model of thinking was input stimulus get converted into internal representations The brain then processes representation, then outputs as actions. Okay. So this came or paved way for growth of cognitive science. In 1956, at landmark workshop at MIT, cognitive science was born as a formal field. George Miller published his famous paper on memory and magic number 7, that humans can hold about 7 items in working memory at once. Noam Chomsky introduced the formal language models. Alan Newell and okay, Alan Newell and Herbert Simon talked about the logical thinking model. Okay, they both were logic theorists. So, human thinking can be modeled like a computer program. It focuses on memory, reasoning, language, and decision making. So, psychology helps AI understands how human think and act, leading to models of intelligence based on information processing. Next, we will talk about computer science, computer engineering. So, we talked about lot of ideas, various fields. Let us discuss about something where AI requires just not the intelligence but also some physical machine to run on it, right? That's about the hardware. Okay. So Alan Turing contributed to building early code breaking machines like the Colossus during the World War II, and Konrad Zuse built Z3 in 1941, the first programming computer, and John McCarthy developed the ENIAC, an important computer, early computers. It was very big, it was filling the entire room. So, the growth of computer power and early mechanical machines. The conceptual foundations go even further back. Computers became faster, cheaper, and more powerful. Okay. So, performance improved rapidly. So, after 2005, shifts from faster processors to multi-core systems were developed. Parallel computing came in, many processors working together. Then Joseph Marie Jacquard built a programmable loom using punch cards. Charles Babbage designed difference engines, analytical engines, first general purpose computer, and Ada Lovelace was the first programmer who suggested machines could play games and create musics. So these are different software contributions. AI uses tools from computer science like programming languages, operating system, development tools. It also contributed back-to-back innovations like time sharing systems, personal computers, GUIs, mouse, etc. object-oriented programming, automatic management, memory management, and so on. So can be added. On summary, computer science engineering provides the hardware and software foundations that makes artificial intelligence possible. Next, we'll discuss about control theory and cybernetics. Before we going into this, how can a machine regulate itself? I mean, how can it automatically operate and control itself? System can adjust itself by getting the feedback. Early self-control system of Alexandra built a water clock with automatic regulation. James Watt developed the steam engine which controls the speeds using feedback. Cornell's created the thermostat, a device that senses the temperature and adjusts the heating accordingly. So these systems showed that the machines can respond to environmental changes. So the control theory formally studies how system maintains stability through feedback. What is the goal? Keep systems output close to desired value. Okay. So it was mathematically developed in 19th century. So cybernetics is a study of control and communication in machines and living beings. It was led by Norbert Wiener. The key idea is behaviorism or behavior is driven by reducing error between the current state and the goal state. For example, you are cold, your goal is to be warm. So you put on a jacket. Simple but very powerful. So, this minimizing of error behavior is the heart of the neural networks, which is achieved through back propagation, adjusting the weights. Okay. So, key contributors like Rosenbluth and Julian Biglau worked on feedback systems. Ross Ashby introduced adaptive systems using feedback. John von Neumann contributed to computational models. So, the important concepts involved here are feedback, where the output is used to adjust the input, homeostasis, maintain the stability in a dynamic system, objective function, a goal that the system tries to maximizes or minimizes. So, in AI, the objective function is what the learning algorithm optimizes. So, the modern control theory focuses on optimal decision making over time, uses math tools like calculus, matrices, and are widely applied in robotics, automation, and engineering systems. So, control theory works with continuous systems, like, for example, temperature, speed. AI deals with complex tasks like languages, vision, planning, but the underlying principles of feedback and optimization unite them. To summarize, control theory and cybernetics gave AI the concept of feedback driven self regulation. So, this is the foundation of machine learning. Next, we'll discuss about the linguistics, our final discipline. Linguistics shows how language works and how it relates to thoughts. It explains how human understands, creates, and uses language. B.F. Skinner explained languages using behaviorism, learned by stimulus and response patterns. Noam Chomsky said humans can create new sentences never heard before. Interesting, right? Languages is not just in imitation, it involves rules and creativity. For example, a child who has never heard the purple elephant danced on the moon can understand instantly this creativity and generativity in language cannot come from mere imitation. So you need to understand the grammatical rules. Chomsky introduced the formal rules for languages. So, based on earlier ideas of Panini, this theory could be modeled and programmed, which was influencing the AI. Then came the NLP. It combines the linguistics and the AI, helps computers understand and process human language. Language understanding is not just a grammar, it requires context and requires knowledge about the world. So, to summarize, linguistics helps AI understand how language is structured and used, enabling machines to process and communicate like human beings. So, when you bring all together, we have discussed about 8 different fields which led to the AI systems. So, the references are from Stuart Russell and Peter Novick and Prag Kulkarni. Thank you so much.